Hello guys, we are back. Our next speakers also ready. So we have a couple speakers for this JavaDay event. Rock stars from Ukraine, Andrei and Oleh. How are you? How are you feeling? Are you ready?
Yeah, fine, good. Thank you.
Hello, hello. Yeah, we are.
Yeah, Project Loom has been generating a lot of buzz in the Java community. And title of your talk is Project Loom friend or enemy of Reactive? It's quite intriguing me. I can't wait to start listening, you guys. So if you are ready, guys, please go ahead.
Yeah, perhaps after previous speakers, it is obvious that Project Loom has no alternative. Yeah. Oleg may complain about it, but we will show something that about Project Loom.
Can't wait for it, guys.
Well, for sure, I'm gonna be complaining a lot. Um, but this is a story not about just complaining. It's something more. You'll see, folks. So, welcome everyone.
You're
Can you?
not sharing the presentation.
I think I am.
We see your screen with the chat.
Yeah, I guess you need to share another screen because currently we see the general one.
Let's try one more time. Window. Okay, entire screen. Okay, that makes sense. Do you see it right now?
Yeah.
Yes, perfect.
Woo! Let's start. So, Loom, friend of foil of Reactive. Let's do a quick recap who we are. My name is Oleh Dokuka. I've been with Reactive for, I don't know, not a decade, since, well, technically Reactive is maybe a decade years old. Well, it's more. I'm lying. It's more. So I'm about being a decade in the Reactive field, doing anything related to Reactive. Started from creating products on top of, well, not on top of, but using Reactive, the special project Reactor, as well as working on Project Reactor. I've been a lead of Project Reactor for the last 2 years and been working on this project for more than 6 years already. So I'm quite a software engineer in Reactive field. Well, Andrew is completely opposite person. He's a fan of imperative, as far as I know, Andrew.
Yeah,
Andrew,
I'm usual Java developer that use in Hazelcast traditional imperative style of programming with many threads, and I'm happy with this.
well, you are, but we always can do better things with Reactive. But before we start this fight, we're going to be fighting with each other technically. Andrew is going to be protecting imperative side and as well as then Loom side, and me is going to be trying to convince him that Reactive is the best solution for everything. But why you want to attend this talk? Because you want to see whether Loom is a solution or not, whether Reactive is a solution or not. So you want to understand and clarify your mind whether you want to use Reactive or you want to get rid Reactive from your code base right away. Figure whether Loom is gonna close Reactive landscape at all, whether it's gonna affect Reactive landscape or not. Well, technically we will summarize it at the very end, since there are some information on that already. In this talk, we're going to talk about problems building modern applications, since majority of you folks are building microservices, server-side applications, and you need to choose whether Reactive or Loom. So this talk is for you if you are in this field. Well, completable feature or Reactive, that's going to be discussed as well in some way. And of course, we're going to be talking about Loom. Well, just to emphasize, we're not going to be talking about the internals of Loom. We're not going to be talking about what is in Loom right now, what is not, what's going to be the future of Loom, etc., etc. No, we are not a direct contributors to Project Loom, so we can't talk about anything related to the Project Loom but the current state of this project. So if you want to learn more about Project Loom, you better go for some owners of this project, like Alan Batman. I forgot the second name of the main engineer. Ron Pressler, right? And look what they talk about. At the same time, we're not going to be talking about Project Reactor, details of the Project Reactor. I'm the person to talk about this, but I already talked about this for many years. So there are a ton of talks about the internals, about the use cases, etc., etc. So you better go and rewatch those presentations from the past and learn what is Project Reactor. Of course, you need to have some knowledge about threads, multi-threading, some basic concurrency, and of course understand some concepts of functional programming. And well, it's going to be nice if you know what is Project Reactor, since we're going to be using Project Reactor in our battle and discussion. But yeah, not about the details. So let's start.
So
In order
what is
to
it?
Yeah, this is actually the app that you and me are building, Andrew. So we are like just entrepreneurs, normal entrepreneurs, software engineers who decided to earn money, as everyone, probably every software engineer want to build something that's going to bring money and make his life brilliant. And me and Andrew are not exclusion from this rule. We want to just do nothing and earn money. Yes. So we decided to build a startup, and like really promising field for many years, even today, is IoT. Like, of course, this is not as shiny and brightly as artificial intelligence and all this LLVM, etc. stuff that everyone is talking about right now, but this is pretty promising field, and we want to build some IoT things related to house, to like owners, to sensors, and we want to build an app that's going to let one to log into this app, collect information about the houses. So this is for rich people. So if rich people are going to use it, we're going to start paying rich people as well. Maybe, or not. Who knows? And in this particular case, user log into this app, see their apartments, choose one which the person want to look at, and see information about sensors that are installed in their apartments. It's not just temperature sensors as it could be, but many sensors. In our particular case, this is, well, really simple and straightforward example, temperature sensors. So it means that in this particular case, we have multiple things in our app. We already have some front end, which we're gonna meet. We have a back end, and we have database where we store information about users. So this is pretty straightforward. In this particular database, we have list of user houses, of course, a list of users. So we let one to log into the system, see the houses, and then choose the one and collect information about available sensors installed in this particular apartment. Really straightforward, nothing complex, and probably, I would agree, the simplest solution to this particular problem is imperative programming.
Yeah.
Yeah, and this implementation is pretty straightforward as such. Nothing complex in there. Indeed, I agree. Well, we make a call to repository, and then we make another call to find all the sensor informations. Well, but that's not it. The second part of it is to collect temperature information. And this could be quite a challenging task. Why? Well, because every sensor is independent software, independent microserver, which can respond to our requests and return actual information about temperature. Well, we started from really simple and naive solution. We don't have like a single hub which collects all the info from the sensors. They have connection to Wi-Fi or I don't know, to network somehow. Doesn't matter, and they are capable to return some information. So we can go ask for some information like current temperature and get response back. So what could be the solution for that, Andrew, in imperative approach?
For this, first of all, we need some sensor client, and this sensor client will take the temperature by the sensor ID. And we could running the traditional loop and going by each sensor and collect the temperature, save it into some array list, and that's all. It's simple, it works fine.
Well, it works, but there is one micro problem, Andrew. Small problem. It's called N+1 problem. Small, big problem, well-known problem. So here in this particular case, we need to go sequentially to every independent server through the network, through the whole world to collect this information. So there is a latency. And the more sensors we have, the more latency, the higher latency we're gonna get. And that's a problem, since our expectations that we set to our users gonna be easily skipped, and we violate everything that we promised to user. So we need to make response time stable. Can we do that, Andrew, is imperative?
Yeah, don't worry. With streams, we can do this with stream parallel. But if you would like to have the imperative, we could use threads and we can use executor service. And with the executor service, we could use the invoke all that takes the list of callables. The callables is the actual logic that go into the sensor, take data, convert it, and put it into the array. And with invoke all, everything will be executed in parallel, and we are finished with this.
Well, sounds pretty interesting.
And pretty easy.
Well, pretty easy, of course. It sounds easy, but one more problem that may appear once we start doing this remote communication is that one of the sensor may not return the response immediately, and we still need to feed into our SLAs. And if one sensor takes too much time to respond, then like everything is broken. Can we just skip maybe this sensor information for now, since this is allowed, and just return what we got immediately? That's going to be something.
Of course. There is invoke all different overloading of these methods, and one of these with timeout. And with this, you will have only the list of sensors that is in this time frame.
Well, interesting. But, it's going to be really promising for every normal software engineer, not involved much in the concurrency, internal details of multi-threading, in Java. And you got me. I know all of this stuff. And if you carefully look into invoke all documentation, you will find out that, first of all, this is a blocking method.
Oh.
Even though it returns a list of features, it is blocking. It blocks the progress immediately. So this is one problem. Second problem, what if one of them gonna throw an exception? So connection failure. Is it gonna cancel everything else? Is it gonna cancel just this one and return what it already collected? I don't know. So. Probably it's gonna cancel everything, throw an exception, and bye-bye. This is, not fine, right, Andrew? And I'm not talking again about that this call is blocking. You wait for all the features to complete, and only after that you get access to already pre-collected data. So technically one thread which is making invocation of this method is blocked and cannot do any useful work in the middle while like features are being resolved. So this is a problem.
Okay, if you're concerned about this, we could rewrite the same logic in a completable future, not in completable, with countdown large way. So we could manually to extract this involve call and create a usual for loop cycle that with countdown large that will go by each sensors in parallel, and in this way we could in manual way try to catch exceptions, and you have mentioned something, and before the large await we could put all our logic that we would like to execute in parallel with our calls, and after this don't forget to call the shutdown now, and that's all.
Yeah, don't forget this, don't forget that. Don't forget how to configure countdown latch. Don't forget that you need concurrent data structure like copy and write and released. Don't forget to shut down your created executor service, since it's going to be wasted resources, since nobody going to close this for you. And many other problems like configuring await, etc., etc., and actually checking whether latch await completed in the required time. But this is minor thing. Andrew, I think it's complex.
No.
I think we can do better. And I'm not talking about scalability, because here we have poor scalability. This is proven by AMDA law. This is proven by universal scalability law, which says the more threads you create, the poorer scalability you get at some point in time. Since all those threads going to be competing for available few CPUs, not like thousands of threads going to be somehow interacting with each other. No, they're going to be managed by kernel thread manager, since this is real threads, and this is going to be poor scalability because of this concurrency and a fair spread of resources between all of them. So no progress, poor performance, since all of them are just fighting for resources, and nothing, no SLAs.
But code is very simple. It is clear for junior, middle, and even for senior developer. And if you're concerned about scalability, let's put another several dollars and rent some extended AWS instance.
Yeah, AWS is going to be happy for you using imperative, since you're going to be paying not just more $100, but more $100,000. And indeed, AWS is going to be happy with this approach. So maybe, Andrew, we can do better.
Why? How? In which way we can do better?
Well, we can use well-known async and non-blocking. And even though you don't want to use like some other external dependencies, you prefer to use the minimized set of libraries that you add in your project, that's okay, because this approach is available in JDK 8. So everyone can use it. Everyone today is on JDK 8 at least. So we can use completable future. Majority of servers supports this async non-blocking approach through completable futures. Majority clients support this approach through returning completable futures. So what you need to do, you just need to write another interface. You just need to use another HTTP client which supports completable future, and we have many of them, and refactor your app and return completable futures everywhere. Well, it's easy.
Make some changes in our code for completable future.
Yes, let me show it to you. So, folks, before we start digging into this area, so this is our app. Really simple Spring applications that we are discussing right now. It has controllers, repository, service. It's Spring application started to everyone. So you probably should be familiar with this code. We don't do anything beyond that. And what you see right now is the implementation that we just discussed. So this is imperative implementation. So Andrew, what we want to do, we want to refactor this implementation. And in order to make this like more software refactoring, we can create a dedicated async sensor service, which of course should have a reference to all the async sensor repositories, They all have to return completable future. That's like a minor thing, you know. We can do that. Everything should be completable future. And then we can start refactoring our implementation. Well, now we can get rid of all this imperative stuff and get completable future. So here's our completable future return from find by user ID repository. And of course, we're not going to be storing this as an imperative approach. We're going to be using functional approach because we are functional programming developers. We should embrace this approach. So we're going to be using method chaining. We're going to be embracing monads and all this functional cool stuff. So we're going to be calling just then compose. Then compose is accepting a function. And this function is going to be called once we find something in the repository in a sync non-blocking way. So we're going to have invocation of this specific function. So we need to implement this function body. This is easy. We don't even have to rewrite anything. We can use some bits of imperative that we had before. And that's it. Easy. We are done.
I think we only done for the first part of the task to take the list of sensors, but not done with the temperature, to get in the temperature.
For sure. Of course, we need to remember that everything should accept and return completable futures, maybe. So we need to also change the type in here. And yeah, the second part. The second part is somewhat challenging, as you said, Andrew. Like countdown latches, etc., etc. But you know, we can get rid of that. We can modify the typing, return typing right away. And here, we immediately get completable feature as well. So this is nice. Now, we don't need all of this. We can use it, but we don't. We want to write everything in truly functional and async non-blocking approach. And we have support for that in completable feature as well. So we use then complete, then compose as usual. We get sensor infos. We implement this body. And now we're going to use recursion in order to enable parallel recursive way to resolve completable futures. And this could be done easily. You know, just like this. You know, I just typed in a second and wrote this easy and straightforward implementation where we create some empty completable future and then go through this list of sensors and combine this list of sensors with another future and then store it back. And then go iteratively through all the sensors and create those features. And since completable features are running right now, we know that because completable feature, when it obtained, it means that it is running. So the process is running, and this reduction, which technically make everything sequential, is just technically make everything sequential. I mean, responses collected sequentially, but this is just a minor thing since we reduce everything into one array and return it back. I like it. This is truly functional approach. Every software engineer that use functional programming does it.
Are you using AI JetBrains extension to generate this kind of code?
What extension?
AI.
AI extension?
AI.
Oh, I don't have this plugin installed. No, I don't.
So, can you write this code by your own?
Yes, of course.
Yeah, I think it is very easy for usual developer with 10 years of reactive background to write the similar code. But what about the usual developers?
Well, I don't know. I have like reactive programming classes where I teach everyone to use functional reactive programming. So I can educate everyone, you know.
And by the way, what about timeouts? In this CodeMS, I don't see it.
Well,
is there or not?
Yeah, we can add it. You know, with JDK 9, there is a dedicated timeout, complete on timeout method, which let one to complete this with timeout. Where that? I already No, it had to be. Yeah, all good, all good. Just commas. All fine, no worries. It's not me missed in this functional pappardelle. It's just right place to apply complete on timeout. Or if you are still in Java 8, which is, well, there is some probability that you are here, you can write a custom implementation of timeout completable future. It's really easy. You know, it's just like this. Just boom. And you have timeout completable features, which is super easy. You have to manually schedule the timeout. It's gonna run and runnable. And then if it's run and runnable before completion of the real response, and you complete it before then, and blah, blah, blah. And then you have to cancel the rest of this. So it's easy, Andrew. And then you can apply it easily as well, like this. Just look timeout, apply either this or that, and the first one, which is going to be completing, going to be returning the result. So the same way for GDK, just a bit of code. It's available in Stack Overflow, Andrew.
Oh, I think I will try to convince my customer to switch on Java 9, then trying to write this kind of the code. Okay. Yeah, indeed. Okay, as for me, it's look like the mess of functional code with some additional operation inside where I should understand every steps and what operation and in what part of the code you should put it. And is it designed to use in this way? I don't think so. It should be much easier. It is Java. Java should be very straightforward and clear language and very intuitive.
Well, I don't know whether it's straightforward and intuitive, but I can agree that it works, although in a bit complex way. But you know, this is, well, I never liked completable futures. It's just you talking about like using less other libraries for security. It's your expert, and you wrote a PhD on software security, not me. I'm fine with using external libraries. For example, we can use true async and non-blocking library. We can use something like Project Reactor, which is even more than just async and non-blocking library. It's reactive. Reactive, Andrew. It's reactive. Reactive.
Reactive.
And what can
interactive?
Well, it's reactive types. It's streaming. It's streaming as well as async non-blocking in a bad way. First of all, it's completely different to completable future, since you have to subscribe. Well, you don't have to forget to subscribe, otherwise nothing is gonna run. So this is another problem that everyone should remember when they start working with Reactive. But this is fine. Everyone can remember that at some point in time when nothing runs at production. But what you need to do, you just need to use Project Reactor, and you just need to use monotype instead of completable future. This is almost equal type, but even better. It has tons of methods. We will talk about that. And it's lazy in all the way, and you can easily combine it. And it's just perfect, Andrew. Just perfect. Just trust me.
Just show me. Is it simpler than using completable future?
It is. So this is reactive implementation of our sensor service, which we're going to refactor to Reactor right now. And as usual, what we need to do, we need to use mono. Or, well, you can use flux, you know, since flux is a sequence of events. But maybe we need to use mono. We will see. This has to be decided at some point in time. So this one now returns mono. Come on. ID works.
You should remove return.
Okay. So find by user ID now returns flux instead of completable future. You can adopt completable future, but, well, Spring supports reactive. There is Spring Web Flux, there is Project Reactor, there is Reactor Netty. So everything is reactive by today, so we can just easily use it. If it is in Spring, then it should just work. So we have the same functional approach, but better. We don't need to use this imperative stuff. We can get rid of it right away. I can just easily command it and use proper thing to find something. It's filter function, and it's filter. It's called filter. You can just use it to figure out whether house ID is the right one. And then if you found nothing, you don't have to throw exception as before in your function. You have a proper language for switching if nothing was found. Switch if empty. And return error. And then you assume that if switch if empty never worked, then you can start handling the result. Found house info. And then request for temperature. Not for temperature, we just need to use sensors repository, find by ID, house info, sensor IDs. And that's it. Easy, Andrew. Easy and straightforward way to handle this. Well, the only caveat here is that technically, well, everything is fine. Perfect. Ideal.
Yeah, for the big case, it is quite easy, but for temperature case,
well, it is easy at this one. Just believe me. Beforehand, we had to mess with this parallelism with complex reduction. Now everything is solved for us, Andrew. Everything. Project Reactor is super rich project. You have hundreds of different utility methods, literally. All of these software engineering backend problems are solved for you. You can do anything, solve all type of problems. We've done that for you in order to make your life simpler, of course. So parallelism is part of Project Reactor, and you don't have to use this mess anymore. You can just use one flat map, sensor info, and then request for temperature, and that's it.
is it some Java stream flat map, or it has something special behavior here?
Well, it's slightly different compared to Java stream. This flat map makes everything parallel. So if you read the documentation, you will figure out that flat map is technically flat in async publisher, which represents async process. It subscribes to it, and it makes everything parallel. So this is by default.
Cool. And timeout?
Well, this is easy. Andrew, this is easy. This is part of Project Reactor. Timeouts, retries, everything that you need to handle proper connectivity with remote server is here. Easy. Just use it. Everything is built in for you, for engineers.
Okay, it looks pretty easy if we are familiar with this API. How many of methods?
I think hundreds. We can look at it. We can decompile flux and see that here we have like...
Yeah, and this is for convenience of usage for engineers. Yeah.
Yeah.
No, hundreds of methods. How many of these methods written by you?
Some of them. Maybe 10, maybe hundreds, who knows?
Yeah. Okay. You convinced me that this code base looks like very easy, but what about a learning curve, about learning some API methods, understanding the reactive concept, and so on? Is it easy to start with a Project Reactor?
I don't know. It's to judge by you, Andrew, and by everyone else. For me, it's really straightforward. Well, you just need to figure out what is flat map, what is concave map, to understand that flat map in Flux is actually parallel flat map or merge map, to understand that concave map is technically the same as flat map in Mono. Well, and maybe at some point you decide to give up with that, but it's better than paying $1,100 to WS. You better pay it for me, and I will educate your every engineer how to use Project
I
Reactor.
understand you. And but we have some statistics about learning curve between coroutines and different reactive projects, and it says that it is not very easy. Also, if someone who is not very familiar with this kind of programming, trying to implement something, it creates a complete mess. Or the person who would like to show its mathematical or analytic functional ability trying to write something, it also will not be understandable for other part of the team. Also, you should not forget about the debugging. When you are trying to debug some of this code, you will not see your own code. You will see the some stack trace with different flux, mono, and internal observable things.
Well, that's true. That's true. I can't refuse it. I just need to admit it that Project Reactor is about functional. Functional is not for everyone. So maybe it's complex. But Andrew, what do you want? What do you want from me? I offered you a proper solution to a problem which just solves what we need.
I think that the answer is obvious. We are talking about Project Loom, and Brian Goetz promised us in this slide picture the perfect future. And the Project Loom should be shining and should solve all our problems. Do you have the Brian Goetz speech? We don't hear the voice. Yeah, but here Brian Goetz said in his interview that he thinks that the Project Loom will kill the reactive approach and perhaps the reactive programming.
Well, yeah, probably sound should be shared as well, but this is a different story. So indeed, Brian Goetz said that Loom is gonna kill reactive, and well, technically
And
it's killing
it's
reactive.
already
Maybe?
done. Yeah, we have for now in Java 21 that virtual threads are here, and as we have seen, it is already implemented in different frameworks. And the next will be the scope, values, and structured concurrency. And when everything will be implemented, we will not need anymore some reactive approaches and reactive libraries.
Andrew, well, that's cool. We can trust to Brian Goetz since he is building Java, the main architect.
And we can rewrite this with I can show how we can use the Project Loom and rewrite everything you have done before with only one small changes.
Well, technically you wanted to say that we don't have to rewrite probably anything.
Anything except one line of code. Let's look at the executors. And now if we will change the cache thread pool on a new virtual thread per task executor, we have done. And that's all.
Well, one more thing. This code is still ugly.
Oh,
And how about server side?
with server side, you are not running this code from method main. You are running it with some Spring Boot server. And as we have seen, it is already compatible with Project Loom. As show our previous speaker, it is very simple to use one property, and Spring Boot becomes a Project Loom friendly, and everything already done. And you shouldn't rewrite or invoke all completable futures or reactive. And the code continue to be very concise, very familiar, and very straightforward.
Well, probably if one run this, it should see virtual thread somewhere. Indeed,
Yeah.
I tried that, Andrew. I tried it with the latest Spring Boot 3.2, and it is easy as you say. But one problem.
And
It's still ugly code.
Is it the ice cream?
No,
No, it looks
no,
like the ice cream and you're happy.
no. It's something different, Andrew.
What problem do you see here?
Well, it's complex. Can we do better?
Complex. Oh, okay. If you would like to do better and trying to do this in a more functional way, we can try to use streams that you are like. I understand that you are like functional programming, like functional streams, and we could um, utilize our invoke all and receive the stream, the futures, and then collect it to the list. And if you are complaining that the invoke all is blocking, we could do better. We could run the invoke all in another virtual thread, and between this new f future, we can call another actions and then block on return with join, and between doing some another things, and it will be very not expensive since we're using everywhere the virtual threads. Of course, if you would like to do it even better, we can write it in a so-called structured task scope way. The structured task scope is the ability to group our task and create some group operation about this task. So we can take our initial list of tasks or callables that should call every sensors, and on each of these tasks call the fork method. The fork method will run the virtual thread that execute this particular task. And then you could collect the results into the future, and using the scope joined until this deadline, you will wait when all of them will be finished with the deadline. And after this, you could go of each of these future and take the list of finished results.
Well,
Yeah.
this sounds interesting, but timeouts. How about like making sure that nothing is cancelled, and if you are in time limit, you just collect what you have. Well, how to extend this?
Yes.
It sounds interesting, but yeah.
Yeah. For this case, if you don't like to use the existing scope, you could create some customer timed scope and put this logic inside of this customer typed scope. So it is very easy to extend. You should only override one method handle complete, that it is automatically executed when some task already finished, and you will receive the future for this. Inside this method, you could implement everything. You could try to catch errors, implement cancellation in some way. And if the results is here, you should put it somewhere, for example, in a results queue. And this results queue could be returned by call the results function. Yeah. And the API from the for the client, for the customer, will be very easy. It will be on the next slide.
Well, this sounds like we should see the libraries implementing this stuff for us. I don't know if every engineer is going to be doing that, because this is going to be a lot of boilerplate since everyone would have to implement it, but I can agree that we can see the future in this. Indeed, I admit that this is promising. But you know, Andrew, the whole approach that we started with is somewhat limiting. You know, going to independent sensor and ask it periodically is complex. It's still problematic. And I think that the approach that we started with can be improved. And instead of going to the sensors and asking them, and we have to remember that maybe sensors are behind the firewall, so we can we can just easily access to them. Maybe they can connect to us and instead stream data to us. So how Project Loom can solve this transparently, easily, in the same way as you demonstrated? Can you show me?
Yeah, you could do this in a simple way. We could use the observer, but this is not a Loom friendly approach, and the Loom will not help with this. So we should forget about it. And for Loom approach, we could use some iterable, without the observer pattern and so on. We could only change our interface. And now from one single double, we could return some iterable, and taking this iterable, we could iterate in virtual threads of this iterable.
Well, take it easy. Let me try it. I need to first understand it by trying it, and then I'm going to be able to say whether it's going to work or not. So this is our original approach that we can refactor. I'm not going to be doing that for now, and I'm just going to be trying to do what you say. So you say we can return iterable for streaming, and our approach should rely on capability of a client to also stream in an iterable way. So here is our iterable method for streaming. And now, how can we do that? We have multiple sensors. Maybe we should just merge it somehow. You say merge.
And use for loop.
Yeah, so we can in for loop execute this process of iterating over every independent stream here. So here we request a stream, and since this is in independent virtual thread, this should technically work. But now how we can transfer this information to the outside world?
Let's create very simple, create some blocking queue. And put the sensor data into this queue.
Okay. So we can use something like blocking queue. Okay.
And if you will block here, it is everything fine because you are in a virtual thread inside.
Okay, and then we can just simply return this queue outside, so one can iterate and subscribe, let's say, to it, and iterate over the content within this queue. It's going to be the subscriber, the one who iterates over is going to be blocked if there is no data, and it's going to see the progress whenever we emit something into it. So, this makes sense. But there are a couple of things, a couple of problems that I see here. So first of all, how we can propagate cancellation. So we start this process, and the futures returned by the submit method are not consumed. So how we can unsubscribe? Linked blocking queue doesn't have this API yet.
You can create some wrapper or extend this queue, or create some small utils library for our projects that everyone in our company will use later.
Okay, how about back pressure?
Back pressure, it is very simple. This is the linking queue, and just put the size of this capacity, and it is solved.
Well, Andrew, it sounds like one should create the whole project reactor on its own, using just virtual threads and Loom, and think about thousands of corner cases like cancellation. And, structured concurrency that we see right now in preview does not solve this. It offers something, but it seems that we should see 1,000 of libraries that start solving those problems for us. And Andrew, I think this is over-engineering. For a streaming case, we already have a solution. This is Reactive. Reactive? Reactive is not about observer. It's not about something that is explained by this Oracle Fox. Loom is not going to kill Reactive, because Reactive is much more than that. Reactive is functional approach. It started from reactive animation. The goal was to combine functional observer pattern and iterable pattern to solve streaming problems. Today we have ton of nice libraries that offers us nice capability for solving streaming problems. And what is important, reactive programming is about programming over a stream of data. That's what we need to solve this problem. Moreover, in reactive streams, we have this brilliant concept of publisher, subscriber with support of backpressure, when subscriber can transparently communicate to publisher how many elements it needs right now. So we don't have to buffer anything. This is just a transparent communication in non-blocking way. So publisher knows how many it has to produce. And moreover, it's been since 2015 there in JDK 9. It's all available. So,
can you show us how it can be implemented with Project Reactor?
Well,
I
think that this is going to be easy. I don't think we have to spend much time on that, but we don't even have to rewrite this method. This already does streaming. We just need to replace this part with streaming dedicated stream method, and that's it. We don't even have to rewrite anything.
Wow.
Easy, Andrew. It's already a stream. Before it was a finite stream, now it's infinite stream.
And
that's all we need.
Maybe solve cancellation problem, but
all these problems are solved. You just take it and use it. You know, Andrew, I would say even more. Looking into Project Loom, I think Loom and Project Reactor can do really nice job together. You know, Loom and Project Reactor can be composed. And you know, if you don't want to write some, and you don't want to use some mono stuff because you don't know whether you need to use Flux or mono in these particular places, you can replace it with imperative counterpart and just use these imperative things for simple scenarios. And whenever you need to use complex things, you've wrapped this into Flux, given that you're running on virtual threads. And then for streaming, you just return iterable. And Project Reactor solves all this complexity that you show me with structured concurrency and this blocking queue within FlatMap already. Easy. Moreover, you know, for all blocking calls, we can just subscribe on a scheduler. And before that was bounded elastic. Technically, well, in order to avoid all these exhaustive platform threads, which creates a lot of competition on CPUs, we can use virtual thread scheduler, wrap it into scheduler, and that's it, and run our blocking calls on a dedicated virtual threads. You know, you can even parallelize everything. Even more, Andrew. Starting from Reactor 3.6, we created a dedicated support for virtual threads, where you can specify that you want to run bounded elastic on virtual threads, and then magically all of your bounded threads blocking calls gonna start running on virtual threads just by using one single property. So you don't have to write anything. You can just specify one property in your app, and that's it. And it's available actually in Spring Framework, so you can configure this through the properties and just have it up and running. So I think it's brilliant.
So you say that inside one project we could combine Project Loom and Reactive approach, and they will not collide with each other?
Yes, I think so. I think Loom is friend of Reactive, and they can collaborate really well. Well, let's summarize it. I think Loom is going to simplify our applications. I indeed agree that we can see a lot of future in that. We can embrace imperative programming when it's needed, and we can combine it with reactive to simplify some complex concurrency orchestration problems. And just one more thing.
Yeah,
Well,
just one thing. Don't forget that the project Loom has some limitation, and for the current moment, it has an unfair scheduling scheme. For example, that the thread or the virtual thread um, will be returned to the so-called pool only when you have some yielding method or something like blocking operation. In other case, if you will have some CPU bound, it will be taking the whole virtual thread and will not give it to other tasks. Also, there are some um, additional problems with virtual threads, but the author promised that it should be solved when they rewrite some Java core internal native libraries. Also, we have some problems that this project Loom couldn't be easily extended by using, for example, by Netty and utilize so-called yield function. But for the most common case, it is ready, and you should maybe not rewrite your code and continue to use the modern frameworks. But in the complex scenarios, when you need some orchestration, perhaps it will be better to look to some reactive frameworks and approaches.
well, sounds like some stuff has to be done by Oracle, and we should still wait for Loom to get stable. So, after all, we can just say one thing. Probably Loom is not going to be killing Reactive right now. We will
But
see what's going to be happening in the future. But thanks God, software engineers are lazy and slow, so this future should to come. Well, thanks everyone for being with us, and probably it's time for
Yeah. Thank you.
questions.
Yeah, it was very interesting. From another side, I could say it was very funny. You did a great job. So, and I can always suggest you to create a dedicated channel on YouTube and every month host the new videos, maybe even podcast. What is very modern now. So it was very cool and very funny. You did a great stand up. So yeah. Let's move for the questions. Yeah. Let me see the questions. So
There
again,
was
we can
some
show the question
questions
on the
in a chat, but we already answered it about Project Loom and reactive programming and coexists in the same application. And the Project Loom better in which scenarios and the reactive approach. I think we already answered it during our talk.
Yes, I could say that this question was given before or in progress in your talk, but there is the question from Frankie de Jong. Could you see this question?
No. Yeah, I see.
So, what is this question, Andrew? Can you read it?
Yeah. Are there specific scenarios where you see Project Loom complementing or even challenging reactive approaches?
Well, I think that like from what I see, the main competition for with like of Loom with Project Reactor is the simple cases when we don't have much orchestration, like just we make one call and then we do another call sequential. We don't have to parallelize anything. And with Project Reactor, you're bound to this kind of colored things. You have to use mono. Of course, you may kind of block things and convert everything back to imperative, but this is not a convenient approach to do so. Um, so for these cases, Project Loom is going to be much more simpler, straightforward, familiar to everyone than project reactor which has like hundreds of methods which works in a specific way, which you have to understand, which you need to understand how to combine them using functional approach, etc., etc. So this is a challenging part. And for those cases where it's just a crude app, you go to database, get response back, and map this response and map it back to network. For those cases, Loom is going to be like the best solution. For cases where you have lots of orchestration, like gateway, where you have streaming scenarios, like Loom doesn't solve it yet. At least we haven't seen it in the JAPs for upcoming JDK 22, 23, 24. Nothing is talking about like proper channel, proper interoperability, proper communication approaches between those threads, between like even methods to transfer your kind of processing. There are no generators and similar patterns which are available in modern programming languages like .NET or Python or JavaScript. So there are many things to solve, and until probably we get there, it's going to be another 10 years. I don't know.
And the question, are virtual threads the same as Go routines? Are you familiar with Go?
I think so. They are pretty similar.
But on the different level, yeah.
Go routines probably similar. I mean, conceptually, this is cooperative concurrency in its nutshell. I don't know the details of Go, but this should be, at least as far as I remember, Java is inspired by Go approach to avoid colored functions and like to avoid this async await as it is in Kotlin and .NET, and just use transparent and straightforward concepts like thread, which is then virtual thread underneath.
And for you, especially, can we use reactive approach with blocking database?
I think, well, we can use it. We just need to create a dedicated thread pool, which is going to be equal to number of connections. Since we know that we are limited in connection pool in any case, we cannot create unlimited number of connection to database. So technically, this is solvable. There are even white papers on this topic from Lightband folks, if I'm not wrong.
So thank you guys for your answers, I guess. Another speaker is waiting us. So yeah, we are limited in time. Sorry for that. But I guess you did great, guys. Thank you for being with us.
Thank you.
Looking forward to the next years.
Yeah, in person. See you in person next year.
See you, Andrew, Oleh. Bye.
Bye.